This video is about the error and warning checks in SUTOOLCSV for SPS1 and SPS2 files. It includes examples of how to deal with several common SPS1 and SPS2 problems. And this video includes how to get your SPS1 and SPS2 files into and out of spreadsheet programs. It also includes the difference between SPS1 and SPS2. But you should watch my video about SPS2 details before watching this one.
SUTOOLCSV will perform error and warning checks as it reads files, and it has options to repair some problems. SUTOOLCSV also facilitates the importing of files into and out of spreadsheet programs. SPS1 files are quite similar to SPS2 files. There are three SPS1 files named X file, S file, and R file, just like SPS2. In terms of geometry update, SPS1 files follow the same sequence as SPS2 files. For SPS2 files, there are two values in the trace headers that also exist in the X records. And there are two values in the X records that also exist in the S records. And also two values from the X records that also exist in the R records. This allows finding and updating all the shot and receiver geometry information. SPS1 files are the same. The most notable difference is that SPS1 files identified shot and receiver lines by names rather than numbers. But Seismic Unix must have line numbers, not names. Here are the character locations of values in SPS2 files. And here are the character locations of the same values in SPS1 files. The most complicated files in SPS are the X files, and the X files are used first for geometry update. So most issues will be encountered on those X files first. Here are some SPS1 X records. The shot line name locations and receiver line name locations are highlighted here. Running SUTOOLCSV with SPS1 options results in these error and warning messages. The shot and receiver line names are not numbers, so error messages appear. Note that sometimes the line names actually are numbers, since it became obvious quite soon that numbers were easier to deal with. We are now going to use the process option trim-Z to make a number out of the shot line name. The documentation for the trim-Z option is shown later, but it basically gets rid of letters while leaving the numerals. Now we use the process option trim-Z again to make a number out of the receiver line name. But another error message about the receiver line has now appeared. Looking at the X file output from SUTOOLCSV, we see that the line names are now line numbers, but the receiver line number is too big to fit in its Seismic Unix key. Two more process options now reverse the sign of the receiver line numbers and subtract 500,000 from them. So now the line numbers are small enough to fit in their keys. A look at the input X records and the output X records and a review of what process options were used. You should understand that the shot line name also exists in the S records, so the trim-Z option will have to be done to the S records as well. And the receiver line name in the R records will have to be processed the same as done for the X records. The documentation of the process parameter. Okay, when you use the process options, you should understand that your goal is to make unique line numbers. Obviously, you know that you cannot just set them all to 1. But you also must be careful not to accidentally turn two unique names into the same number. Onward to looking at the use of spreadsheets. Going back and rerunning the previous setup without the process options. The resulting X records contain asterisks where the line names used to be. asterisks are substituted wherever SUTOOLCSV could not read a number. If your input file had a few bad fields and thousands of records, you would be able to find them easily because they would now be asterisks. But for the line names, this creates a problem for the use of spreadsheets. You don't want asterisks in the spreadsheet. You want the actual line name. The W-type option, CSV chop, allows you to get the line names into the spreadsheet. The CSV chop option simply puts a comma between all fields as it outputs the records. This produces a CSV file with everything preserved, including the line names. Now, spreadsheet programs can already chop up fixed text files and input their values into columns. So what is the point of doing this? The answer is that the files output by SUTOOLCSV always have some CSU records put at the top. I have not been showing you those until now because they were not relevant. But spreadsheets are a good place to discuss them. First, load the file created by the CSV chop option into a spreadsheet. Now we see that the line names have gotten into the spreadsheet. Once modified by your choices in the spreadsheet, it can be output as another CSV file, and that CSV file can be used directly by SUGeomCSV. Or you can convert it back to fixed format SPS file using SUTOOLCSV. Just a reminder why you needed to use the CSV chop option. The 6 CSU records are generated by your option choices in SUTOOLCSV. The first record preserves your choice of match keys for use by SUGeomCSV while updating traces. The second record determines which of the following records are data records. The third and fourth records indicate the C language format to use when SUTOOLCSV writes the values. Note that this format is ignored by the spreadsheet program. The fifth and sixth records specify the names of the values below them in each column and other information related to the values. For example, in column G is 30 underscored GRNLOF underscore 37. Between the 30 and 37 is the Seismic Unix key name for shot point number. The 30 and 37 themselves are the character range from which the value was obtained. And it is the character range where the value will be output when SUTOOLCSV creates a fixed format file from the CSV file. And yes, you can modify the 30 and 37 manually and get SUTOOLCSV to output the values into that character range. This is a general facility of SUTOOLCSV, which allows you to construct many types of fixed format files from spreadsheets. Looking at columns M and N, you can see that the receiver point key name gaps in 2 places on record 6. You can also see RF and RT, which stand for receiver from and receiver to. You can see a similar thing in columns I, J, and K for the channel range. But instead of the channel key track F, you can see match E1, which means use the key name on the end of the CSU match record unless overridden by the match equal parameter. And you can see that column C has match 1 in record 6, which means use the first key on the CSU match record unless overridden by the match parameter. These match substitution names allow you to use different key names during SUGeomCSV updating if the field record or field channel numbers are not in their proper keys. I advise you not to rearrange or delete spreadsheet columns until you are familiar with all this. I am going to review the unrepeat option because it is initially quite confusing when you need to use it. Also, it gives some idea of the other error and warning checks that are performed by SUTOOLCSV. SUTOOLCSV performs channel range checking. This means that it examines the segments for a shot and issues error and warning messages if the channel ranges are wrong or unusual. For instance, if a segment for a shot specifies channels from 1 to 20, and another segment for the same shot also specifies channels 1 to 20, then something is wrong. In fact, two segments hitting even one identical channel number is wrong. The legitimate checks for channel range errors will also produce false positive error warnings if the same FLDR number is reused later in acquisition. These are X records in which you can see that field records 7, 8, 9 are repeated later. Running this setup for SPS2 X file gives a large number of error and warning message. Add the unrepeat option to the setup, and all the error and warning messages are gone. Basically, the errors are caused by the fact that SUTOOLCSV and SUGeomCSV bundle all the X records for field record 7 together, and therefore think that it has 8 segments, with many identical channels being specified. The unrepeat option uses the order of X records and the order of traces to distinguish between duplicate field record numbers. You should understand that the unrepeat option relies on the order of records and traces. Relying on the order of things is not very safe. Therefore, I was reluctant to add this option. So, you should perform a lot of review when you use it. You should perform a lot of review anyway, but even more so here. Documentation for the unrepeat option. It should be understood that spreadsheets can output CSV files. But CSV files are not SPS files because SPS files are fixed format files. The spreadsheet and the CSV files can contain all the values in an SPS file, but they still are not officially SPS files. So if you need true SPS files, you have to convert them to fixed format using SUTOOLCSV or some other program. Basically, the setups here show how that works. This image shows the results of actually running the previous setups. As a bonus for getting to the end of this video, the next image shows how you can convert SPS1 files into SPS2 files. The basic reason you can convert SPS1 to SPS2 and vice versa is that I have arranged to put the values in the same position in the CSV files, which mean they are in the same columns in the spreadsheet. What if you don't have SPS files? You can, of course, use old observer's notes to create spreadsheets for 2D surveys.